Hello, this is Mohsen, and welcome to Origami on SolidWorks videos. In this video, we will draw an origami Miura-Ori pattern, a circular one, on SolidWorks. So, this is the final shape of the circular origami Miura-Ori pattern. First, it starts from a single unit cell on a circular parameter. This circle has a diameter. The diameter has a relation with the parameters of the unit cell. So we have to do some uh, parameters, relations, and formulas. The formula of arc length will make up the unit cell parameters and the dimensions. So S is related to the radius and the uh, the angle of the unit cell that describes the length of the overall unit cell. So S, the arc length of the unit cell. So let's set some fixed parameters. Let's say that the arc length is fixed as 50 millimeters and the theta or the angle of the unit cell is 30 for uh, for a clear and solvable parameters and relations. And we will have a radius of 28.6479. So we will have these three dimensions, the diameter and the angle of 30 degrees and the arc length of 15. So as you see, this is the dimensions of the unit cell of the Miura-Ori pattern on a circular circle. So this unit cell has dimensions, and these dimensions is related to the diameter and the angle that make up the whole unit cell. The dimensions you can adopt from any reference that's on internet, or you can make them from any reference by equations and relations. We will draw the first shape based on these dimensions of a diameter 57.3 millimeters. Now let's jump to the SolidWorks. First of all, we have to set the units of mmgs, millimeters, grams, and seconds. Then we will draw as indicated on the unit cell dimensions. First, we have to draw the circle diameter of 57.3 millimeters. And then we will set those three lines of separation of 15 degrees. That will make up the unit cell. A unit cell is compensated by three cross sections. The first one, the second one of an offset of 4.25 millimeters, and the third one is like the first one on the line of the parameter. So let's jump to SolidWorks. First, on top plane, we will draw a circle of a diameter 57.3. And then let's make these lines. Okay. And the third one, let's set the dimensions of angles. Here is 15. And the second one, also 15. See, this will add up to 30 degrees. So we'll have a segment of a unit cell from here to here. Okay. Now we have the first thing is the circle diameter. is up, and we can draw the cross sections on it. First, the unit cell is, as indicated before, I said that it's compensated of three cross sections. So we have to draw one cross section and duplicate it on the other cross sections because it has the same dimensions of 10 and 2 millimeter thick and 72 degrees. As I said before, that dimensions is you can adopt from any reference, so you can change them. First, we have to make a reference plane on this line and this line and this line. To make the cross sections are must be rectangular to the parameter. Okay, so let's make a reference plane. Let's choose the first line and then choose perpendicular to the top plane. Okay, this is the first plane, and let's make the second plane for the second cross section. The cross sections will be on these planes. Okay. Now we have the three planes and is ready to draw the three cross sections on it. Let's start with this plane and draw the first cross section. Let's make it just perpendicular on it. Okay, and start by a line from this point. Let's start from this point and draw the cross section. And set the relations between the lines. These are parallel and equal. Okay, and also these are parallel and equal. And these four are equal. Okay, this point must be on the same line on this point, so these are vertical. And this must be equal and parallel. Okay, and this point must be on the same line on the second point, so these are horizontal. Okay, we haven't done any dimensions, just the relations between the lines. Now the dimensions are a wide width of 10 millimeters and the degrees of 72 and 2 of thickness. Let's do the dimensions. 72 degrees. Okay. And 10 millimeter width and a thickness of 2 millimeters. Now it's all done. We will have the first cross section. Now let's jump to the second one, just making a copy of the first one and paste it, Control C, and choose the second plane, and let's hit Control V. Okay, the problem here that the second cross sections having an offset of 4.25 millimeters from the parameter. So let's make this. Let's make an edit and move this cross section let's make it on the same line as the parameter. Okay, choosing this point and this point, make them vertical so they will be on the same plane or on the same line. Okay, and having an offset of 4.25. Now these are good. Let's make the third one. The third one is the same as the first one. So copy paste. Now we don't have to see these planes. Let's hide them. Okay. The idea is how to link these cross sections as a curve on the parameter of this circle. See, these circles, these cross sections are having a curvy path between them. So if we can make uh, extrude or a looped bus, so there must be a path, a circular path that links the cross sections together. So first, let's check if that's true. Let's make a looped bus base and choosing the profiles. The profiles uh, are the cross sections. Okay, let's check this cross section and the second cross section. See, these cross sections will make a solid, but we don't have a path. If we choose this, this is not a link between two cross sections. So this is not helpful. And if we just make it, it will not make a curve on the parameter. It just make a straight line. So we will make this as a curve on this one. Okay, let's just delete the looped bus and make a path from here to here. Okay, and from here to here. How to do that? Let's check the 3D sketch. 3D sketch, let's start from the right half and draw a line from this point to this point and this point and this point. Okay, let's just make a copy of this circle, convert entities, and make this segment from here to here just to make a line from this center of the line to this center of the segment of this circle. So let's make a trim for this. Okay, now we have just this segment. So will be linked to this line. Now let's make a center line or a line from this center of the line to the center of the curve of the circle segment. Okay. Now we have to set the dimensions of it. We will not vary these dimensions. It's just the same. Okay. Let's now draw another line from that center of that line. This line has a center, and let's draw a line parallel and equal to that line that we just draw, this line. Okay, here. Okay, that must be equal and parallel to that. Parallel and equal. Okay, let's just delete this to the z-axis and make them equal and parallel. Equal and parallel. Okay, this line will help us to make a curve from here to here through this line. Let's choose a spline from this point through this line till this point. Now this is our path, okay, as indicated here. Let's see if there are an offset. See, this is the circle, and the path of this circle of these two cross sections is directly indicated and have the same tangent line of the circle. Okay. If we want to make the second half or the second path, we should make another 3D sketch. This is a second 3D sketch and do the same steps. Let's link these 3 points and make a copy of this circle as a convert entities and trim it. Okay, let's make those 2 lines. And that's of okay. Let's make another line on that. On this line, start from its center and equal and parallel to that line. Start from here. Okay, let's just delete that relation and start new relations with that line. Parallel and equal. Okay, now all is good. Okay, let's do the spline. The spline from this point through this point till this point. Okay, our path is now good. We have 2 paths and 3 cross sections. Now let's use the feature of lofted path base. Let's choose 2 cross sections, this and this, and choose our path guide. See, now it's curved. It's curved on the parameter. Okay, the second half, let's do the same. Choose this surface and this cross section. Let's choose the curve guide. This is the curve. Okay, all linked together will make a whole body. Okay, now we have this shape. Okay, this shape. We want to make this one. If we want to make this one, we have to choose to make a patterns, a circular one on the parameter of the circle, and the second one of a linear parameter or pattern. Okay, let's make a circular pattern. First, if we have to make a circular pattern, we have to make an axis for the circular to make this unit cell revolve on it. Okay, let's make a new sketch and making just this line must be on the axis. See, on the axis, horizontal or vertical. Sorry, vertical. Okay, let's choose circular pattern. Now this is the direction. Let's choose this line and we have to choose bodies. So this is we have to make it as a body. So it is a body and choose it. Okay. First, we have to choose instance spacing. Instance spacing will have the space between between each unit cell. Let's start from 2. Okay. This from here to here, the angle, this is the angle, degrees. From here to here, the angle, how much? Okay. From here to here, the angle is 15 and 15, so it's 30. 30, let's make it 30. 30 degrees. So between two unit cells, we have 30 degrees. Let's make this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 unit cells on these parameters. Each unit cell make up a 30 degrees. So we have a ring. This ring, we can make it as a linear pattern. So we can make a whole cylindrical shape of the Miura-Ori pattern surface. Let's make a linear pattern. The direction is also this line. Okay, we can choose the direction of it. And let's choose the bodies and choose each unit cell. 12, 1. Now we have to choose some parameters. So spacing and instances. The diameter or the distance, D1. The distance is here. The distance is from each unit cell. So from here to here, let's say from here to here is 10 millimeters. So we just set it as 10, and we can make how much rings we can make. Let's make, let's say 6 or 10. Okay, 12. How much we want, we'll make it. So now we have a cylindrical origami Miura-Ori pattern on SolidWorks. We just draw it from a just a circle, then developed by unit cells, a unit cell by profiles, and link them by extruded lufted boss base, and then made a reference cross section and circular patterns to make these circular and cylindrical Miura-Ori pattern on SolidWorks. I hope this is helpful, and thank you for your time.